Okay, 2.6, the second part of 2.6. We're gonna have to do a couple things. First of all, if we wanna solve this, what do we need to do to solve this?
Subtract 48.
Group it. Group it. Anytime I have something over a square, you need to start thinking group, if possible. Group it, okay? So if I group this right here and I group this right here, what can I take out of 2x cubed minus 3x squared?
X squared.
X squared. And that means you are left with 2x minus 3. You want that to basically match what is over here. So I need negative 32 to get down to 2. How would I do that? Take out a negative 16?
Yeah.
Okay, let's see if that works. So then I would get 2x. What's 48 divided by 16?
3.
And since I took out a negative, it should change the sign to this. Okay? Now, these are the same. This and this come together to make one set of parentheses. This and this are the same thing, so I do not need to repeat them. I just turn them into one. Okay? What is this here?
Perfect square.
Difference of squares. Which factors to what?
4.
X plus 4, X minus 4.
Thank you, Talia. 4. Okay? So then, when I go to solve this, that means x is greater than negative 4, right? X is greater than 4, and x is greater than,
3 seconds.
well, yeah, 3 seconds. I'm just gonna say equals 2 right now. This sets up your parameters, correct? This sets up your parameters for where it's turning and curving, okay? Those are my intercepts and it sets up my parameters, which means I have a parameter like this. Negative infinity to negative 4.
That's a lot of work.
I have a parameter from negative 4 to 3 seconds. I have a parameter from 3 seconds to 4. And I have a parameter from 4 to infinity. You understand how I got all those parameters? Okay. This one comes from, I take whatever's least, in this case negative 4 is the least number, right? So my graph, because this is a cube, technically it could turn 2 times, right? Mm-hmm. We're going to check it in a second. I set up all these parameters and then I'm going to check to see what it looks like. Okay, which is how they're having you do it in your homework. So if I do 2x cubed minus 3x squared minus 32x plus 48, and I graph that.
You notice?
I need a larger window in the y minimum. Let's do negative 100 to 100, and let's count by 5.
If it wasn't for the makeup on my shirt.
So my rough sketch of this looks something along that measure. Okay, it's gonna be some type of like curvy in type thing. Okay, and I changed my window so that I could get it to fit on here perfectly. This here tells me that at negative 4, this should be negative 4, it turns and goes down forever. Okay, it's continuing forever. This here tells me that from negative 4 until it reaches, technically it would be 3 seconds. So until it reaches here at 3 seconds, okay, that's another turning point. Yes?
You got those by putting them all together, like
Correct.
making all this possibilities.
Mhm.
Okay.
Yep. This, when I get to this turning point, I now turn from that 3 seconds all the way back up till I get to 4.
And then 4.
And then from 4 to infinity, I continue going up forever. Okay? That's what those come from. So when I have 3 things that x equals, I have 4 sets of parameters. Yes?
You go back down, like to the negative infinity.
This?
How did you get negative infinity?
Because this parameter is negative 4 is the turning point, and so I know it's going to continue on forever.
How do you get them coordinates?
From x equals negative 4.
From what x equals. So x, when I factored it all out, right, I get all these, I set them equal to 0. X equals -4, x equals 4, x equals 3 seconds.
Right.
So shouldn't the -4 be in the X spot?
No, because -4 is the lowest x-intercept,
Yeah.
but once it crosses through that x-intercept, it's still continuing on forever, this graph is.
So for the first one, it's always gonna be infinity.
Negative infinity to something.
That's what
And the
I'm-
last one should always be something to infinity.
So that's what I'm saying, why you put, 3 seconds first if it was X?
Because
Oh,
look,
I'm tweaking.
I have 1, 2, 3 turning points, yes?
Yeah,
This is where I turn.
right,
This is where I turn.
right.
This is where I turn. Those are all my intercepts. So because I have 3 turning points, I have to have 4 parameters,
Alright,
okay? If I had 2 turning points, I have 3 parameters, okay? Yesterday when we focused on parabola ones, we had 1 turning point, but we had 2 parameters, yes? Okay, so you're always gonna have 1 more parameter than turning point.
I have another question.
Yes, ask it.
Why wouldn't you do -4 for, like, why'd you do -4 3 halves?
Because 3 halves is 1.5, right? And if
Yeah.
I think on a number line, -4 is here, 1.5 comes next, then 4.
Mhm.
I can't skip over that parameter, over that x to that 4.
Okay.
Does that make
Make it go
sense?
least to great.
Least to greatest, does that make sense?
Yeah.
Okay? Okay, and then what they're gonna have you do once you set up these parameters is do what I did. Plug this original equation into your graphing calculator and see if that makes sense. Which means you might have to change your window. My window is very large on the y. It's negative, I think I did -100. Yeah, -100 and 100 on the y. But my minimum, my x is still -1010. Your windows can be different. And I counted by 5 on the y. So that when I graphed it, I got the full picture of what was happening. Okay? So you might have to play around with your window a little. And if I press the trace,
We're gonna make it.
and if I press the trace feature, you can trace over to where it crosses, and you can see that it says 1.5. Well, that would make sense because this is 1.5. Okay? So you can trace it all the way over and see every place that it crosses on the x-axis, and it should match these pretty closely, within a couple decimal points.
Who got my paper wet?
Okay. From there, we have to solve ones that are in fraction form.
Multiply by x minus 5.
You wanna multiply both sides by x
No,
minus
you
5.
first need to set it equal to 0, probably, right?
Well, I don't
Yeah.
know, what do you think?
Set it equal to 0.
You wanna set it equal to 0 first?
That's how you solve it,
Okay,
right?
right.
Right.
So you wanna say 2x minus 7 over x minus 5 minus 3 is less than or equal to 0, yes?
Mm-hmm.
Yes.
Now what do you do from there?
How you do? Let me see this.
Multiply by x minus 5.
5 to both sides.
I
That's your
Add 3.
comment, now everybody know.
Well,
X minus 5.
what did you say?
It's like
Who, me?
Who said common denominator?
Tyler did.
So that you can
Yeah, Tyler.
combine this and this together, yes?
Yes.
Your common denominator is
One.
x minus 5, correct?
I'm
Okay.
lost in the sauce.
So if I multiply this by x minus 5, you get 2x, well, it'd be over x minus 5, right?
Oh,
You
be
get 2x
2x
minus 7 over x minus 5, and then you would get, I'm gonna put plus,
3x.
negative 3x plus 15. I distributed that so that it would be plus like that.
Then you jump.
So then you get-
just add.
What?
Then don't you just add?
Add like two.
And then, what's it called?
Mhm.
Cancel.
Just like, yeah, add like terms, cancel stuff out. What's 2x and negative 3x?
Yeah, I-
Or negative x.
Negative
Yeah.
x.
Something as, something.
Negative x, what's negative 7 and 15?
8,
So you get this,
x minus 5 is less or equal to 0.
negative x plus 8 over x minus 5 is less than or equal to 0.
Can't you cancel out your x? No, you can't.
No, you can't cancel anything out,
That's tough.
but now you have to think because this is a rational function. It is a rational function. And there are rules that go with rational functions with graphing, okay? Like, you have to know how to find your domain and range on here. You have to know how to find your intercepts on here, okay? What are some key things that I can look at? Okay, the bottom says x minus 5, correct?
Yeah.
Okay, the top says negative x plus 8, yes? Okay, if I take this bottom portion, x minus 5, and I set it equal to 0, what would x be?
5.
If I take the top portion, negative x plus 8, and set it equal to 0, what does x become?
Negative 8.
Nope,
Oh, 8.
8.
Because you divide by negative 1.
Those are my parameters. I have to take each piece individually. Okay, I need to take each piece individually and then set up some stuff.
No, we make.
So tell me, so there's gonna be 3, good, there's gonna be 3. What's my first one?
Infinity.
Negative infinity
And
to
5.
5, and is it a bracket or is it a parentheses?
Bracket.
Okay, what's the next one?
I didn't even know, I just guessed.
5, what? 5 to 8. And what's the last one?
8
8 to infinity, good.
So I know 8 to 5? Why is there no 8 to 5?
It is, it's 5 to 8.
Wait,
You have to go least to greatest, yes.
what's the difference? How would you know whether it be bracket or?
I don't have 2 grades.
When it's less than or equal to or greater than or equal to, it's a bracket. It will include that number, meaning that number can be a solution of this problem. Okay, so now I have that. So now, what do you think I'm gonna do? Well,
Put in the calculator.
let's do some testing points like we did yesterday, remember? We took points from this, we took points from here, we took a point from there, we decided if it was negative or positive, so we knew what our graph is supposed to look like. Okay, so if I plug in what number you wanna plug in?
0.
A 0, good call, Cameron, that's smart.
Yeah, I can.
If I plug in a 0
Way to
there,
have a smart
I get
thought.
negative 7 over negative 5, well, if I plug in a 0, I get 8 over negative 5, right? In my simplest form. So you get negative 8/5. That would be a negative, yes?
No, like,
Output.
I can't do it.
Guys, stop talking. If you plug in, Morgan, focus. If you plug in something between 5 and 8, what do you want to plug in?
2. I mean,
Between 5 and 8? I think.
7.
6.
12. 6.5.
Let's just plug in a 6. If I have a negative 6 here, what's negative 6 plus 8?
Negative 2.
How about positive 2?
yeah.
And if I plug in a 6 minus 5, I get 1. So you get 2 out. That's a positive outcome, yes? Okay, and then pick something between 8 and infinity, and don't pick a crazy number.
1.
10. Negative 10 and 8 is, what? What's not true?
You know Muslims.
We're not doing that, we're just seeing what the outcome is when we put it in here. Is to positive or negative outcome, because that's gonna tell us how our graph looks.
10.
Okay, so negative 10 plus 8 is negative 2, and negative 10 and negative 5 is
Negative 15.
negative 15, yes?
I think someone back here knows.
Then you have negatives.
Wait, why is it negative 10? Wait.
If you plug in 10,
10 minus 5 equals 5.
oh, down here, sorry, that's my fault. So it comes out negative, right? It's negative 2 over 5. So look, the graph goes negative, positive, negative. That tells me my type of curves. I'm heading down, I'm heading up, I'm heading down.
So it's like one of them things over there.
Yeah, like one of these things.
Yeah,
So
it's
then, we put that into our calculator, okay? We're gonna put, the equation into our calculator and check to see what that looks like, cool? And you have to use parentheses. If you don't use parentheses around each of these individual sections, then you're not going to get the correct graph, yes?
Is it the one that you're putting in or in that one that you?
Put in the one that you simplified.
Okay, great.
Thank you. Oh, I have way too big of a window this time. Shoot. Change the window. Okay, and you're going to get a function that looks like this. Okay, it's something. Ooh,
It's an arrow.
like this.
Oh, I remember.
Remember our asymptote switch and all that stuff happens and we create those? So that's a rough sketch of what it looks like, which makes complete sense because it's negative, positive, negative. Okay? And that's what we're doing on these. We're solving them algebraically and then you're checking them graphically.
Wait, so what do you plug in for those graphs?
You plug in what you have as your simplest form right here.
Okay.
You gotta get them two to four.
I thought.
Okay, don't make it more complicated, plug
Wait,
in
do we
the
also have to plug in the less than or greater to 0?
Do you also have to put in what?
The less than or greater, or equal to?
No, you're just plugging this part in. You have to put parentheses around this, divide it by parentheses around that,
Okay.
okay? And you will get that type of graph. And that's what it should be because this is a rational graph, Anytime it's in fraction form like that with x and x, it's a rational graph and you're going quadrant, quadrant, or you're going quadrant, quadrant, quadrant. So you're gonna either have 4 quadrants or 6 quadrants to graph it. Okay, two last things, stick with me for a couple more minutes.
Those,
Guys, stop talking. Okay, finding the domain of an expression. How do I find the domain of this? The square root of 64 minus 4x squared. Sort of. Because it's in a radical, I'm not setting it equal to 0, I'm setting it greater than or equal to 0. So I have 64 minus 4x squared is greater than or equal to 0. From there, what do you think I do? Take it out of it. Yes, when I put it as greater than or equal to 0, that's how you take it out of it.
Take the square root of both sides.
I don't even need to take a square root yet. What are you gonna do? Thank you, Tyler. Take
Yeah,
out a
Tyler.
4.
Oh my goodness.
If I take a 4 out of this, okay, I'm gonna flop this as I take the 4 out too, so that you can see I have negative x squared, right? And then you have plus 16, correct?
Yes.
Greater than or equal to 0?
Yes.
Okay.
Can we add
and you can take, hold up, you can take a 4 out of it. You can place
Son
the,
of a biscuit, what are you doing?
It's a difference of
x
squares.
plus 4 and x, plus minus 4.
Can't you just subtract 16?
Right.
Okay, sort of,
Would
Cameron.
it be negative x plus 4 and x plus 4?
Yeah, subtract 16, go for
No, Jeremiah, you don't need to do that
How
one.
you gonna subtract 16 from 0? You gonna get-
It is right, it's a difference of squares, it's just a difference of squares
With a
in
negative.
a different form than you're used to. Instead of the 16 being the minus, it's the x that's the minus. So it should say something like
So 4 is in the front?
4 minus x and
That's crazy,
4
bro.
plus x. Yes?
What?
Okay?
He called you homo, cuz.
4 minus
did he
x,
really?
4 plus x. From there, you're gonna get your parameters, okay? From there I get it. Now because this is a radical, we have to do some thinking. So here x would equal 4, and here x would equal negative 4, yes?
Why don't?
Radical functions, what do radical functions graph like? When it's a square root function?
Wait a minute.
Oh, shoot.
No, I just got.
I remember this.
Wait,
Radical
would it really
functions.
matter if we did it that way though? Like, couldn't it still be x minus 4 and still get the same thing?
Yes, but,
It's radical
Does that
functions.
just look
Doesn't
aberrant?
it graph like that from
It just
the
looks cool,
origin?
that's what.
okay, sometimes, yes, Morgan, if I have a true square root function,
That's not
just
true.
a parent function that's a square root, it graphs like this, right? From the origin, okay? This though gave me parameters. What are my parameters?
4, negative 4.
Yeah, I'm gay
So
for
my
Jesus,
parameters look like this, negative 4 and 4.
bro. Jesus gets me.
Meaning, at negative 4, I have an x-intercept. At 4, I have an x-intercept. So what do you think that's going to look like? If they have to touch both of those points.
The thing is,
Why?
Rabble up,
Yeah, that-
rabble
The little U-shaped
Savannah's
thing.
saying it, yeah, it's like an arc, okay, like this.
And then you don't get to find
Like the thing in St. Louis.
Do you need to find the turning point?
Yeah.
Not, that's not what it's asking us to do right now. So here's the deal. This is considered something that's considered a closed interval, okay? Do you see how I only have one interval? From negative 4 to 4. Those are the only solutions of this problem, or of this quadratic,
Because it's just like
of
connected.
this square root function, okay?
So you shut
So
the
it is
door.
closed, because I can only go from here to here and plug things in. These ones are not closed, they're continuing on forever,
That's crazy.
okay? That's why I have brackets around both of these, because they're closed intervals. So you have to be able to recognize that and see what's going on. Last thing, word problem.
I got Tourette's.
Okay, it says,
For real.
And you will probably need a graphing calculator to solve these ruler problems, just so you know. You don't wanna do it by hand. A projectile is fired straight upward from ground level with an initial velocity of 384 feet per second. During what time period will the height of the projectile exceed 2,000 feet?
Oh, I got you. So you have negative 16 t squared,
Okay,
and then for your VOT,
yeah,
you have 384 feet because that's your velocity.
good. So I have
And
negative 16t squared plus 384t, yes?
and then you plug in your 2,000 feet for your SO.
So I'm gonna say that it needs to be greater than that, because that's what the
Greater.
problem's asking me, right? When will it exceed?
Yes.
Meaning it has to be greater than that, okay? So from there, I can solve. What do I need to do to solve this? What would you do first, probably? Make it easier on yourself and get,
Subtract 2,000.
no, make it easier on yourself and get rid of what?
Divide by
Negative.
16.
I mean,
A
it's
Divide by
negative.
16.
Yeah.
The 16 t, right?
Divide by negative 16, what, Maddie?
but you can take a T out.
Because we're
That's
trying
what I
to
thought.
find like a
Well,
range of things, we're not trying to find a specific.
Maybe you keep the t in because if you
We are
take the
using
t
this
out, there'll
formula,
still
we're
be
just
a.
not using like it
I don't
equals to
know.
something, we're trying to find an inequality, so we change that. So negative 16, and we get t squared minus, what's 384? 24, thank you.
Cadence, stay sure.
Greater than 2,000 divided by negative 16, which would give me negative 125, yes? From there, what do I do? Now tell you, what do you do?
Subtract 2, the,
Add 125.
yep.
Yeah, Mercedes.
T squared minus 24t plus 125 is greater than, oh wait. My sign should have switched, yes? Because I divide by negative. It's less than 0. Now, what do I do from there? What do I do from there? Can I factor this? Can something multiply to give me 125 and add to give me negative 24?
Yeah, yes, 15 and, is it 9?
Let's ask.
15 and 9.
15 and 9, no, 15 does not go into 125.
You got Google on your laptop? Oh, well, she said let's
Hey,
ask
Siri.
Google.
Nine,
Bring out the
15 and
calculator, like.
Does
I knew they was
anything
advanced, but-
go into it?
15 and 9.
15,
Jenner.
Okay, Jenner.
I love Jenner.
guys,
Wait,
15 does not go into
That was
125.
135, Jenner.
It doesn't.
15 does not
Hey,
go
I
into
was, I was thinking.
Yeah, Jenner's a great guy.
66 to 120. Oh yeah, I just drew. I was thinking.
Okay,
like,
if it is not
50 goes into
factorable, what do
4,
you have to
60
use?
times
No solution.
No.
Quadratic formula.
Quadratic formula.
Attaboy.
If it is not factorable, you have to use the quadratic formula. What is the quadratic formula?
Negative
Equals
3
negative
plus or minus radical v squared.
Over
That's what it sounds like.
This is too much stimulation for my brain. I don't know what's
You're
happening.
too much stimulation.
My, opposite b plus or minus square root of b squared minus 4ac
All homogeneous.
Oh, no.
all over 2a.
So just all over 2.
Over 2.
So you get 24 plus or minus the square root of
Like, come on.
Because you called.
576. Guys, stop talking. 4 times 125
500.
over 2.
76.
So 24 plus or minus the square root of 76 over 2. Half of 24 is 12, right?
Half of 76 is, I don't know.
76 does not have a perfect square, does it?
No.
But you can divide it by 2, can't you?
So 76 breaks down
38, right?
into what?
Oh, it's in the square root of thing.
Yeah,
Well, 8 and 9 is 72.
2 and 38.
So 2, yeah.
That's a big number.
Which is
38 and
19.
19, right?
And 19 doesn't have anything. So it's 2 radical 19, so I get radical 19. Because the 2's would cancel out technically. Okay, so then do 12 plus radical 19, and you would get approximately 16.4. If I do 12 minus radical 19, you get,
No main error.
oops, that was wrong.
That's a congruent sum.
Yeah. You get approximately 7.6. So your two solutions, okay, your two like intercepts of this would be those 2 points.
16.4 and then 7.6.
Yes, so you take the 7.6 and you say 7.6 is what compared to T? Less than T, and T is less than 16.4. There's my parameters. Okay?
Done.
So a test will verify that the height of the projectile will exceed 2,000 feet when it is between 7.6 and 16.4.
Oh, we done.
That's all your answers.
Bruh.
So your answers is a range of numbers,
What's a projectile?
like when you
Spit.
launch something.
Like a Nerf gun, the little bullets, that's
Yeah.
what I'm talking about.
Travel that fast?
Yeah,
Okay?
they made a new one.
No, you're fine.
Yeah, it's like